these two examples, we're looking at a special case, sum and difference of two cubes. And those special cases are up on the top of this example worksheet, where to factor the sum of two cubes, this is the formula that we use. And for the difference of two cubes, like D is, that is the formula we use for that. So we're going to apply each of these formulas. And for a sum and difference of two cubes, those are ones that you will be given on the quiz and the test. So it's just your responsibility to recognize when we have those two special cases. So now, to apply that to this, and again, in this first one, the first thing you always look for is a greatest common factor, which in this case, we can factor a 2 out to start with. So we have x cubed plus 8 left. And both of these are perfect cubes. Cube root of x cubed is x. The cube root of 8 is 2. And again, what it means to be a cube root of something is very similar to square root. The cube root of a number, the cube root of 8 is equal to 2 because 8 is equal to 2 cubed. That's the definition of a cube root. So you're basically asking, what do you cube to get 8? The answer is 2. So, factoring this, we have 2. Now you realize in this first set of parentheses, we basically have the cube roots of what we have here. The cube root of a cubed is a, the cube root of b cubed is b, so the cube root of x cubed will be x. The cube root of 8 is 2. That's the first set of parentheses. And then you'll notice that the second set of parentheses stems from this first set. The first one is a squared, so x squared. And then the product of a and b, so we have x times 2. The product of these two, we have 2x. And then finally we have b squared. 2 squared is 4. So that's what we have left. And then with both of these cases, there is a pattern with the signs that you use. Notice here we start with plus, and with the sum it goes plus, minus, plus. Here we start with minus, and it goes minus, plus, plus. Well, the pattern that follows with these is always same, opposite, plus. If you look at this, it goes same, opposite, plus, same, opposite, plus. So in this case, since we have plus here, it's going to go same, opposite, plus. And I will clean this up just a little bit and put that x there. So this is the factored form of this. And again, once we start throwing these into equations, then you would set each part equal to 0, and you're able to solve each piece of that. Because now you can solve these quadratic equations. Now, in the second example, there is no greatest common factor that we can factor out. So then we're ready to jump right to the two sets of parentheses. And the first set is the cube roots of this. The cube root of 8x cubed is 2x. Because if you take 2x times 2x times 2x, you end up with 8x cubed. And the cube root of 27 is 3. Because 3 times 3 times 3 equals 27. All right, then the second set of parentheses, again, it goes square, product, square. Square, product, square. So the square of 2x is 4x squared. Don't forget to square both of them. The product of 2x and 3 is 6x. And the square of 3 is 9. So in that second set of parentheses goes square, product, square. In that order. And again, we'll follow the same pattern with the signs. Same opposite plus, since we're starting with the minus. Same opposite plus. And that is the factored form of this difference of two cubes. In the next video, we're going to look at how to factor polynomial expressions that have more than 3 terms.